Physics students, good afternoon. Mr. Fugit here. Today in this video, we're going to be examining a topic we've been covering over the past couple of weeks that we have called momentum. We've treated momentum as the vector product of an object's mass times its velocity. Okay, so in this video, we're going to be looking at a couple of different objects and how they, some of the conditions they need to have to be moving with the same amount of momentum. This problem is specifically geared towards problem number 6 on homework 11, which covers over momentum and impulse. Problem statement goes like this. A bowling ball of mass 6.8 kilograms moves in a straight line at 3.36 meters per second. So we have a ball, bowling ball, moving in a straight line at a velocity of 3.36 meters per second. Now, because this is a bowling ball, it's somewhat massive, 6.8 kilograms. Okay? The rest of the problem statement goes as this. How fast must a ping pong ball of mass 3.009 grams move in a straight line so that the two balls have the same momentum? Now, just in terms of their size, a ping pong ball is noticeably smaller. We're told the ping pong ball has a mass of 3.009 grams, so it's going to have a much, obviously, smaller mass than the bowling ball. And the question is asking us, well, what does the speed of the ping pong ball need to be in order for their momentum values to be equal? Now, obviously, we know really what's going on with the bowling ball here. A large mass and a decent velocity, somewhere in about the 7 to 8 mile an hour range. But the ping pong ball, because it has a much lower mass, in order for its momentum to match that of the bowling ball, it's going to need to be moving much quicker. Something that we have to pay attention to here are our units for mass, right? The mass for the ping pong ball is expressed in grams because it's a much smaller object. So I'm going to go ahead and convert that into kilograms right off the bat. So I can divide by 1,000 or move my decimal 3 places to the left. That will give me 0.003009 kilograms. Now that's a few more significant figures than I typically like to use, but it's really just the numbers that we have to go with because it's what we're given. So what I'm going to do here, as the first thing I'll do is I'm going to find the momentum of the bowling ball. Okay? So I'll call this momentum, P sub B, for the bowling ball. And I'm just going to take the mass of the bowling ball times its velocity. So 6.8, I'll leave my units off to save space here, kilograms, times 3.36 meters per second. Okay? So our mass, kilograms, our velocity in meters per second. So we'll multiply those together, 6.8. If I turned on my calculator, times 3.36, we're left with about 22.848. This is the momentum of the bowling ball. 22.848 kilogram meters per second, or as we've been learning, Newton seconds is also an appropriate way to present that unit. Now the problem statement is asking us for the condition under which the two objects will have the same momentum. Now, we know the mass of the ping pong ball is very low, meaning in order for its momentum to be equivalent to that of the bowling ball, it's going to have a very high velocity. So here's what we're going to do. We're going to take this momentum of the bowling ball, P sub B, and I'm going to set that equal to the momentum of the ping pong ball. We'll call this P sub P for the momentum of the ping pong ball. So 22.848 is our momentum for the bowling ball, kilogram meters per second. We'll say that is equal to, well, our momentum equation is mass, which we know, 0.003009 kilograms, times some velocity that we don't know. That could look a little bit better, my apologies. Now, algebraically, when we get to this point, in order to get this velocity term by itself, we need to divide over our mass. So I'm going to take that 0.003009 kilograms. I'm going to divide that value on both sides of our equation. Now, I canceled it out on the left-hand side because we have that value in the numerator and the denominator, so that value will cancel out. And now I'm going to plug in 22.848 divided by 0.003009. When I do, I get a velocity value that is 7,593.2. I believe. Here we go. Meters per second. Kilogram meters per second divided by kilograms leaves us with units of meters per second, which are velocity. Now that does seem like a very, very high velocity, so I'll check my answer key. 7593.2. That's right, what we got. Now I talk about this a lot in class, but we have to remind ourselves when we get very large or very small numbers, we have to think, is there a context for why that's occurring? And here, there is. Right? Because our momentum for the ping pong ball has to match our momentum for the bowling ball. Remember, momentum is a product of mass and velocity. Okay? So, in order for the momentums of those objects to match, we know we have a very small mass, meaning we have to have a very large velocity for that momentum to equal a ball with a very high mass and a low velocity. Okay? Those are both proportional variables when it comes to our momentum, so we have to make sure we understand why that number is so large. Again, don't be afraid of big or small numbers, right? We just need to understand why they are the way that they are. So hopefully this gets you going in the right direction, solving this problem when we're setting the momentum of two objects equal. Good luck.